So we are learning to identify and describe relations and functions. So as we learned in Unit 1 and 2, a function is a relation where each x value has one y value. So we can see here, it means that here we've got -3 is only has the y value of -4. -1 has only the value of -1. So it means that no ordered pairs can have the same x coordinate with a different y value. One clear graph we can see this on is when we're talking about the circle. So if I draw on the side, hopefully I can see this x value is going to have 2y values. So this wouldn't be a function. That comes into this vertical line test. So the vertical line test is if I draw a line straight down, if it intersects in two locations on the function, it is a function. So if it intersects on two places on the graph, it is not a function. Whereas if it intersects only in one, for example, a parabola, it is a function. So please do a vertical line test for you to be able to check whether it is a function or not. So let's check if these are a function and then look at the domain and the range. So it's just going to be looking at the ordered pair. So 2 goes to 5, 3 goes to 6, 4 goes to 7, 5 goes to 8. That means it is a function. We can see our domain are all possible x values, which is 2, 3, 4, and 5, and range is all possible y values. If we do the same thing for our next pairs, we can see the x value has 2y. So straight away, we know it's not a function. The, the domain is focusing on my x values, and my range is focusing on my y values. So this is just some notation on what we can write. Instead of writing y, we would write f of x. If we're wanting to natural a function, if it is a relation, then we are going to be writing it as x comma y for a condition. So let's have a look at these two. Sketch the graph of each relation, then state the range and domain and specify whether it is a function. So x squared, can you have a go at graphing this? Y equals x squared plus 1 is a parabola that has just been vertically is translated up by 1 unit. If I do a vertical test, I can see straight away that it is a function. Because we're given x elements straight away, even though the question is asking us what is our domain, we know our domain is what's been given here. So it will just be -2 to 2. To find the range, we just need to look at what is our highest point and what is our lowest point. So our highest point will be when x is 2, y is 5, and our lowest point will be when x is 1, which is at the turning point. It's inclusive of those values because we've been already told that. So we include it in the range and the domain. If you look at the next one, x and y condition, um, x squared plus y squared equals 9. If you can't see that, that would be a circle. So remember, it's at our 9, we can write it as 3 squared, and it will be our radius. We've got a radius of 3. There is no horizontal or vertical shift because it's just x squared and y squared, which means our circle is starting at the origin. We are told our x elements are -3 to 3, so that's why we've gone 3 to -3. We also know that if we do a vertical line test on the circle, there are 2 points it's intercepting, which means it's not a function. But with a circle, whilst it's at the origin, our range and our domain will be identical. So it's just going to be for both of them, -3 to 3. What is the maximal domain of the function f of x equals log 3x over x minus 1? So if we draw this straight away, we can clearly see that our x values, our domain start at 0 or get as close as possible to 0 and doesn't reach and continues to infinity. Likewise, our y gets as close as possible to 0 and goes all the way up to infinity. So that tells me that it would be 0, comma infinity for my domain. Just be mindful that it'll be like it's there. It can't equal 0, so it'll be a rounded bracket. Our range will be the same. What is the maximal domain and range of f of x equals 3 minus 5 to the power of x? First thing you need to think about always is being able to draw it and visualize it. So we know that it's going to be f of x is equal to 3 minus 5 to the power of x. We can also see here that there's going to be an asymptote of 3, and there's going to be an asymptote at 1 here. So this helps us out in terms of our domain. It means that it will not equal 1. It's going to be all the way down to the infinity. For my range will be the same thing. It will be 3 is the highest point. It can't equal to it though, but it's going to go all the way down to infinity. If I look at this one, what is the domain and range of f of x? Is equal to 4 minus x squared. Same thing, we note it is a parabola. It's negative, so it will be a maximum, and it's starting at 4. The next part I'm going to look at is what is my domain. Well, we know with a parabola, it's going to be infinity on either side, or they'll just continually go. So in this regards, that my domain will be all real numbers. If I wanted to look at range, my range is really starting at the 4 up here, and it's going to go as down to a fit negative infinity. Now, it can be equal to 4, so I'm just going to change my bracket to the square bracket. Function notation. So we've learned some of the function notation in Unit 1 and 2. We need to understand the words of image. So when it says the element y is called the image of x under f, or the value of f of x. Be mindful of that. We're going to go through some of these questions. So with function notation, I like to break it down like this. A function is called f, is defined, which is the column, my domain, which is -1 to infinity. How I draw it on the graph, it contains all real numbers, so which means it's going to be a line. Then I've got my rule function. F of x is equal to x squared. If we want to break it down further, R just means it's real numbers. So if I look at this, it's going to be grouping it fully, whereas Z is just having on those integer points. So let's have a go at writing this one first. So this first one here, it's got x comma y condition is y equals 4x minus 1. So straight away I know that's linear, so it is a function, so I can write it as f colon. In terms of my domain for a linear, if it's not set, a linear will go on for all real numbers. So I can put it as real numbers. So just be F colon real numbers is written with all real numbers, comma, the function equals 4x minus 1. If we look at the next one, it's got 3y minus 2x equals 9. So this is where we know it's linear still, but before we do anything, we need to make sure we transpose it to get y by itself. So we've got 3y, I take 2x to the other side, so it becomes 3y equals 2x plus 9. And I divide both sides by 3, and I get y equals 2/3 x plus 3. It'll be the same as what we had before, as we're talking all real numbers, um, and we're going to be grouping with all real numbers. So we write it exactly the same, we just instead to get the y by itself to change it to f of x. Let that working out now. The next part, 3, is we are going to look at y equals negative x squared plus 5x. So in this case, again, the main thing you need to know when we're dealing with this is with a quadratic, the domain is all real numbers unless we're told, and we're told what domain we're looking for. It's between -2 inclusive and 3 inclusive. So instead of saying real number like we've done, we're going to be writing -2, 3. Everything else is the same. Likewise, the last one, it says y equals 2x plus 4, comma x is elements are all real numbers. So it's going back to how we did at the start, where we just got saying real numbers is the domain. So the function f colon d, it's described by all real numbers. F of x equals 6 plus x has a range of 3 and 10. So we're trying to find out what d is, our domain. Because we're told what range is, I can substitute that into my equation as my y value. So I've done that. Instead of saying y, I've got 10. Instead of saying y, I've got 3. And I can solve for x. If I solve for x, that tells me what my domain will be. My domain will be -3, that should be comma, 4. And it's inclusive because my range was inclusive with my brackets. If I say what is the range of f colon in brackets inclusive of 3, comma 9, tell real numbers of f of x equals 2x minus 9. I do the same thing that I've done before, but this time I am going to substitute my domain in my equation. So I'm going to start off with my equations again, but this time I've just substituted the 3 and 9 into x to find my y. So I get -3 and I get 9. So that tells me my range. Oops, there should be y is equal to -3 and y is equal to 9. So that tells me my range is going to be -3. So let's have a go at these two questions. Let's see how they look. Okay, so the first one, we know that when we've got on the bottom x minus, if I draw my graph, how do I know I'm going to have an asymptote at 1 here? Because that all end up being 1 minus 1 is 0. So I'm just going to bring one from asymptote. Another asymptote I'm going to have is on the axis right here. So I'm not worried too much about that one. I'm still labeled it in there. So because we've got squares, and normally if we didn't have this squared, I would have my graph here and here. Undo that. And instead, because we've got the square there, it means my graph is going to be getting as close as possible, and it's going to be positive. Oops, but at least you can see what I'm trying to show you. So this tells me straight away a few things. In terms of my domain, there's all real numbers except where is the asymptote? The asymptote is going to be at 1. So my domain is all real numbers except for 1. My range is going to be all positive numbers, but it's never going to equal 0. So this is where I am able to, again, do the round bracket, say it's not going to equal 0. It's going to go to infinity. What if we at g of x equals 2x squared plus 5x plus 2? So this is an graph, which we know is a problem. There's a few things we need to work on. Because we're just looking for a domain and we're looking at range, the main things I want to know is literally where is the turning point. There's multiple different ways we can do that, and I'm just going to run the whole thing just to help us out and be able to visualize it for those that are still struggling with some of the basics. So the first thing I'm going to do is just label my intercept. The y-intercept is x is 0, y is 2, but that's always going to be the c. The next part that I'm going to do is I'm going to factorize. So straight away I'm looking for two numbers that times together to equal AC, and AC is 4. And two numbers that add up to equal 2B, and B is 5. So straight away I know it's going to be 4 and 1. So I'm going to use amount to go 2x squared plus 4x plus 1x plus 2. I will factor out the 2x and have x plus 2, and I'll factor out the 1 and have x plus 2. So that gives me 2x plus 1 and x plus 2. So now I've been able to do that. That tells me my x-intercept. The first x-intercept will be at -2 when one of these is equal to 0. Spaces out. And the other one will be at negative. Now, to find the turning point, we are going to use part of the formula on the quadratics. Just part start with space. So that means to find the x point, it's just this part here on the quadratics formula, negative b over 2a. So my b value is 5, so it'll be negative 5 over 2 times 2 is 4, so negative b. So negative 5 over 4 is negative 1.25. That will be approximately somewhere here to a dotted line. So that will be the axis of symmetry, which is smack bang right in the middle. So now I just need to find out where that is going to be. So I'm just going to be plugging in that value into the calculator for x to find out my y value. So that gives me, once I put it on the calculator, I know that I've got negative 1.25, comma, negative 1.125 as my turning point. I'll just label this. Okay, so that tells me it's going to be slightly more than -1 there. So it'll be approximately here. And it tells me my graph. Drawing a graph makes it a lot easier to visualize. So straight away now I'm able to write down my domain. My domain we already knew would be all numbers, it's just my range. I know it can be equal to -1.25, comma, that will go up to infinity.